It's endeavor number 16, but it's our very first convergence-divergence test, the geometric series test. The geometric series test says if R is in between 1 and -1, it converges, and not only does it converge, but if it's geometric series, I know what it converges to, and that is huge. In Chapter 9, half the time, we won't know what it converges to. We won't be able to find it. We just know that it will. So this is huge. We not only know when R is in between 1 and -1, but also what it converges to. And if R is anything outside or equal to 1, or outside or equal to -1, diverges. So then we saw examples on Friday. Example. Let's go to number 3. Can you guys still see if I zoom out? No. All right, let me zoom in. I want us to do more practice before we go on to 9.3, especially because we have a quiz on 9.1 to 9.3. Let's make sure we have it really good, then we can ace it. Now, if it helps, why don't you write out the first 4 terms? You don't have to do it in your head. Write out the first 4 terms. If you cannot see whether or not it's geometric series, write out the first 4 terms. Then ask yourselves if it is or not.
It is geometric series.
It is. Don't just ask yourself, is it? If it is, but also, what is common ratio? That's the whole key.
1/2.
1/2. So first of all, geometric series. Remember how I was explaining everything on Friday? I'll come back in. You explain everything for these tests. I have to make sure that you process through the whole test, because some are easier. This is easier. Some are harder. Geometric series. R is equal to 1/2, since 1/2 is in between 1 and -1. The series converges and converges to what would S sub n? What would S sub infinity? What would the sum equal? Formula is A1 times 1/1 minus R. It can be A1 over, or it can be A1 times 1/1 minus R. Same thing. Did I get it right? I simplify, and I have 1/2 over 1/2, which is just 1. 1/2 over 1/2, which is just 1. How about number 4? Any questions on number 3? Does it make sense? -1? Plug in 1, I get -5/4, right? Plug in 2, I get positive
Is that n or pi?
n.
Oh.
N. Good question. N. I know, it looks fuzzy. Bad picture. If it's 2, I have positive 5. Do you guys see where I'm getting numbers? Does it make sense?
Yeah.
If I kept going. Is it geometric?
No.
Is it? On top?
Yes.
On bottom?
Yes.
I think so.
Yes.
It is geometric, but what would my common ratio be?
Negative 1/4.
Mm-hmm. Negative, right?
Wait, is it pi or is it n?
N. Yeah, it's N. A sub 1 times 1 over 1 minus, another parenthesis, right? 1 minus negative 1/4, positive 5/4. So negative 5/4 over positive 5/4 converges to negative 1. Or the sum. The sum converges to negative 1. Does that work? Can we do one more? Maybe two more. You guys go. I want you to do last two on your own. Some of you might be able to think through and just mental math it and say, geometric series or not geometric series? Just hint, if it's not geometric series, right now we have to say, I don't know. So probably geometric series.
Is
but
that n or pi?
Tan of pi over 4 to the power of n. Can you see? Tan of pi over 4 to the power of n. Can you see difference? Can't you see difference? I can see difference. Pi, n. I want to be able to understand you too. Mandy, I want to understand too. No, it's okay, keep talking, but I want to be able to understand. So you need to talk. What are you asking, Ethan? Are you thinking through what terms are?
Yeah.
Oh, okay. And Mandy, what are you answering? Geometric or not?
Because
Geometry.
it's geometric, but since n equals to 0 and then pi over 4 is 1, so a is equals to y is divergent.
Starts as 1, right? So anything to 0 power is 1. And then tangent, what is tangent of pi over 4?
1.
1. So 1 to the 1, 1 to the 1, 1 to the 1. Is it geometric?
Yes.
Yes. Why is that important? If it wasn't geometric, I'd have to say, I don't know. We only know one test, and the one test is geometric series only. Why is it geometric? What could I say R equals? Times, times, times.
Does that mean it doesn't converge then?
Series. You guys are right. Diverges. Done. One is not between negative 1 and 1. Open, not closed. Open, right? So therefore diverges. Good. Diverges to? No. Just diverges, right? That's the whole point. Doesn't go to anything, right? How about bottom one? Did you guys get there yet? Plug in 1. Plug in 2. Plug in 1. Or 3. Plug in 4. Geometric series? Yes. What does R equal?
Negative 1.
Mm-hmm. I know, I gave you easy ones, huh? Well, kind of, a little tricky. Does that make sense? Does anybody have any questions? Geometric series. Is it? Yes or no? Yes, perfect. I have a test. If it's not between -1 to 1, diverges. If it is between -1 to 1, converges, and I can find to what? I can find infinite sum. Okay, but there was another test that we just peeked at a little bit on Friday. We need to learn this one. Divergence test. These are the two easiest tests. Geometric series and divergence. If, now hold on, wait. What does A sub k stand for? Sum? What does A sub k stand for? Or A sub n? Not the sum.
Frequency.
Not frequency.
A term.
Terms.
Yeah.
Divergence test, or another way of saying it, is the nth term test. It's called, we're trying to think of the nth term, and if I'm going to infinity, I'm trying to think of the infinity, well, you can't really do that, but I'm trying to approach the infinite term. So first term, second term, third term, where are the terms going? Here's a nice test. If the terms approach or converge to anything other than 0, the sum diverges. If the terms approach, remember what we did in 9.1? We saw whether sequences converge or diverge. That's all we have to do for the divergence test. Now hold on. I said if it doesn't equal 0, then it diverges. Hold on. If it does equal 0,
There's always a
may or may not. So I need you guys to not only in your forever card, not just write the test, but also write the note. Because one of the beginning mistakes of sequences and series, one of the beginning mistakes of testing convergence of series is limit of terms is 0, converges. Limit of terms is not 0, diverges. If not 0, diverges every time. If it is 0, I don't know, and neither do you. Cannot prove anything if it equals 0. Test doesn't work. Test fails. Divergence, that's why it's called divergence test. It's not called convergence test, it's called divergence test. It only can prove divergence, cannot prove convergence. It proves maybe, but maybe doesn't prove anything, right? We're getting 2 examples. This is endeavor number 17. But first, can I show you a quick little flow chart? Kind of flow chart. When we look at, ready? At the very beginning, what are you given as a problem? A series, right? And series shows terms. First term, second term, third term, fourth term, plus. First of all, take the limit as you go to infinity of the terms. First of all, take the limit as I go to infinity. So see if the sequence converges or diverges. Not the sums, but the sequence. If the limit does not exist. If the limit does not exist, divergent, right? Because not 0. If the limit does not exist, not 0, so divergent. If the limit exists and is non-zero, if the limit equals 1 or 5 or e or pi or divergent, not 0. If the limit is 0, I don't, neither do you, no. Okay? Let's test. Let's test. Okay, first one. Now, if you wanted to, could you start writing out terms? Could you say 1 plus 2 squared 4 plus 3 squared 9 plus 16 You can always write out terms if it makes it easier. Geometric? No. Okay, if not geometric, limit as n goes to infinity of n squared. Does that equal 0? No. Equals infinity, right?
Oh, you're right.
Not 0. Therefore,
You see why? Also, oh yeah.
does that make sense? The nth term test or divergence test. The nth term is easier because we think diverges converges in lots of the tests. So nth term test diverges. Why? Not 0. How about this one? We could plug in or we could just go straight to taking limit. Cool kids, show off. How would I take limit? Infinity over infinity. No. L'Hôpitals. I could do L'Hôpitals, right? What happens? Where am I going? Infinity, right? I'm still going to infinity. Is that 0? No. What do 3 dots mean? Therefore means it's mathematical language. Therefore, since it's not 0, diverges by the nth. True?
Yes.
See, do we still have to like do whenever you look test or write LH? Like we need
Theoretically, but I'm not going to be too picky on it. Because I'm hoping now that you don't need to. Next one. You could write out terms, not geometric series. We know this one. What's limit? 1. But, limit exists! Not 0.
Happens.
So therefore, what's it doing? Diverging. Yeah.
You have to do this for an FR group. Do you have to put which test it is?
Yes, probably. Or like they could do a multiple choice and say which test proves convergence or divergence, and you have to know which one applies. I'm going to skip down a little bit. What if we go to number 5? I know you guys could do number 4. What if we go to number 5?
0.
0?
Yeah.
Why, Ethan? How do you know?
I think it's fun and
Wait.
Wait, is there an Endeavor card?
Yes, there is.
Endeavor card, something over n factorial. Who's stronger?
the bottom. Factorial.
The factorial is. Wait, even e to the? Mm-hmm. Factorial is stronger. So therefore, this one is 0. What can I say?
You don't know. You don't know.
That's all I can say. I don't know. Maybe, maybe not. This test won't tell me. I don't know. Real quick on number 4, just so we have it. This one does diverge. Hopefully you can see why. Bottom one, or number 6, what do you guys think? Diverge or converge?
1 over 2.
Yeah, because same thing, I have tied degrees, and so tied degrees, even though factorial, I can still say, But what's still not equal to?
It's not equal.
Not 0, so going to be ... diverges by the nth term test. How about the bottom one? What's the limit of the bottom one? 0! Yay! Therefore what? I don't know anything. Maybe? Maybe not. So right now, is it okay to say don't know? Yes, but only when I'm taking limit of sequences and limit equals 0, I can say, I don't know. Doesn't have to diverge. With that, kiddos, we are done with section 9.2.
Thank you, go back.
Homework, tomorrow. La tarea, have it done. Okay? Spot check. Spot check section 9.2. Spot check section 9.2. That's homework 44, right?
Oh, 44.
44 is 9.2. We didn't start 9.3.
Excuse me.
We didn't start 9.3, guys. Not that homework. Homework 44, due tomorrow. Endeavor quiz. Be studying. We must know our formulas and our tests, or else we're stuck.
In the homework, 47. The answer says diverge.
37?
47.
47. Oh, no. Who's stronger? This one, 3 to the n, ln 3. 3 to the n, ln 3, ln 3. 3 to the n. This one, 3n
this
squared,
one's stronger?
6n. Top stronger. Infinity. Yeah, infinity.
Yeah.
Alright, kiddos, we got it all? We'll do tests tomorrow. Let's leave it. We'll have ignorances for this. Oh, no. I have this one, but this is Jacob. Check in the locker. I haven't seen it.
Hi, Missy. How are you?
I am doing alright. How are you doing, kiddo?
I am doing okay.
I'm fine
I'm
with
insanely
living
tired.
alive.
I said I'm doing